account question. This topic that's been fairly popular in the last couple of months. Lots of Twitter, lots of Discord, lots of discussions, lots of Medium posts. First, I had this slide myself for a couple years. After this time, now says 20 years of experience in video. Well, the picture's black and white, so you can't see how much my hair or grays is starting. That's it. I've been part of the alternative pathway for, well, basically the start since 2017. And I've been one of the current core developers ever since. In order to say something about account abstraction, we first need to establish the traditional blockchain picture. When we talk about blockchain, we typically think about the key pair. I have a private key, typically a seed phrase. With that, I can sign transactions on blockchain, and that makes things happen. This is fairly static. The blockchain developers picked perfectly. You sign using this. If you lose your key, well, good luck. Your account is gone. Well, the account is there, but your ability to access it is gone. Most blockchains also have some sort of notion of smart contracts, where you associate it with an account and store logic that will execute. Most blockchains also allow you to store states with that logic. But at the end of the day, every time you want something to happen on chain, you need to sign a transaction, and that transaction will make either funds move from account A to account B, or a contract run a function by logic, maybe moving funds around, maybe doing other things. Then there's also the whole UTXO type of chains, which works similarly but different. Let's not associate them with this stock. That's another story. But as we said, this is fairly static, fairly well, non-flexible. You can sign your transactions, and that's it. And for many years, people have been wanting something which is more flexible, more easy to use. And this has been the account abstraction. And the thing that is abstract is the logic with which you validate transactions. That's the part they have abstract. And basically the idea is to let a smart contract validate transactions. And this will make accounts more programmable. And there's a bunch of different goals, targets, ideas which you want to achieve with the account abstraction. First, it is arbitrary verification logic. You can implement different of the signature protocols. You can delegate authentication, and whatnot. You have trust funds and whatnot. The second part is the account security. As we said before, if you have a basic account, lose your key, well, all of this lost. And here you can implement things like some sort of social recovery, and you can have some sort of a backup key, and you can implement time blocks there, you can have spending limits, you can implement different things in terms of what. Another track is that in many situations, especially when we're trying to onboard new people, having to have tokens or funds in their account to do a transaction is a hurdle. So the ability to be able to sponsor transactions is also crucial here. If possible, it's nice if you can pay with other commodities, like you can have an ERC-4337 token, and it would be nice if you pay gas with that instead of Ethereum, for example. And there's also certain ways of bundling operations together so that you can make even more atomic swaps and similar. Those of you who have been to eternity events before might find this, well, yeah, you can program goes there. It sounds vaguely familiar, I hope. I did some internet scrolling and I found a blog post from Comparative about the Fortuna hardware coming in June. It doesn't have a year here, but the year is 2019. And this blog post contains this. And one of the major features of the Fortuna hardware was that Germany introduced generalized accounts. And they address two main issues currently experienced in blockchain customers. And the first one is the lack of flexibility when you control your accounts. And the second is requirements to own an account in order to load smart contract data. So, very similar. The ideas are there. The ideas about account practices is even older, but the term we use is pretty early in the development. I actually gave a presentation about this in Prague, in work. How many of you were there? I see. If you want to look at it, it's there. I will make a short recap of what the generalized accounts is for the sake of the story. In eternity, the generalized account is an account which has a contract attached to it. That contract is responsible for verifying the transactions. And we do this in two steps. Where the first step is you attach contracts to your normal account. So you can have an account, one of those private key pair accounts, and you can upgrade it to your account. Attach your contract. And that contract will have a specific function which you target, saying this is the function I want to authenticate. This is a normal contract, so you can interact with it as a normal contract. Totally update and save. Then you can also act as authenticating. Then when you want to make a transaction, you use the second special transaction, which is called the meta transaction, where you take just your normal transaction that you want to sign, and you wrap it together with the data necessary to run the authentication function. Presented like this, it sounds fairly simple. Writing that logic for authentication function is tricky, and it's really important to get it right because, well, this will authenticate the transaction, so any error means that, well, you will basically make a security code, or maybe you can lock your funds in if there's no longer any way to make that authentication function return true. So a lot of care has to be taken when you write the function. On the high level, it's deceptively easy. Nice. Of course, there are some limitations because this authentication function has to be run on speculation by miners. So we really limit to no more than 50,000 gas, which is only 60 of the micro, so not a lot of gas. So the miners are willing to run this effectively. Because if the authentication function says, look, you can't do this transaction in a block, so that the miner is actually wasting gas. Otherwise, you know what to write on and see if that. You're not allowed to change the state of the chain in your authentication function. Well, except for your own state, of course. You're not allowed to move tokens around in the authentication function. That you have to defer to the actual transaction. You can't do remote calls, and also this authentication function runs in a special context because we know that there is this wrapped transaction. And in order, for example, if you want to sponsor something, you might want to have a look at that transaction. So in this specific context, you can also look at it. Generalized accounts has developed a bit over the years. That initial release, in the first update, we made sure that inner transactions does not revert. The first prototype or the first release version was a little bit of a prospect. And if you had the inner transaction fail, it would just revert and not toss anything, which is, of course, a bug. So we fixed that. And we added some extra support in order to do authentication with zero-knowledge proofs. That's possible. In the next part of the another step, we added more things to this transaction deflection, looking more details of the new transactions. And in the next part, which is not yet set in time, there will be more updates. We will extend the transaction context. We will add a network ID that you can look at automatically, which is nice. In the context of hypertext, if there are multiple chains, it's nice to see on which chain you are, so you can make verification work on the particular chain. And that would be more support for binary language. It makes it also easy to write sophisticated functions. This is all good and nice, but we have this sponsor idea. We want to be able to sponsor transaction of someone. Generalized accounts can pay for transactions, but they will be run by the generalized account. If you want to run it as a separate entity or a separate account, that's not possible. So we also added another transaction to the ecosystem where you can pay for a transaction. With this wrapper, we can do exactly the sponsor case. I can create a transaction, Philip can pick it up and pay for it. This is really nice guy in back. And if you combine that with generalized accounts, you can wrap a transaction and pay for, and the generalized account can pay for it. Out of nice. So if there is a specialized use case, for example, someone is promoting a new DAF and interacting with that particular contract should be free for a while. They might put some initial tokens in there and paying for the first 1,000 transactions of this contract. Then with the inspection, you can wrap contract calls to pay for them automatically if they are calls to the right contracts. So this actually resolves quite a few of those account contraction challenges that arose. At the same time, Ethereum and other blockchains have also been discussing this, of course, because it is a really nice idea. I think the earliest discussion I saw was from 2016. There are a couple of, or at least 3, abandoned or not agreed upon attempts to bring this to the Ethereum blockchain. The first one, the ERC-4337, has a lot of similarities to generalized accounts, but only taking at a few of them. They had adding abstract non-sounding and simple verification. And then there's one which aims and divides into single tenants and multi-tenants, signing situations. And then there's this third one which focuses more on this variable response messages. And the ideas with these are they are all consensus breaking, which is a bit of a thing because Ethereum is, we have to face it, it's a slightly bigger community than the return community. And a consensus breaking change is therefore also a slightly bigger thing. And enter the ERC-4337, which is a way to do this in a non-consensus breaking. And also, the first 3 months tackled 1 or 2 of the use cases, while this one tackles almost all of them in one suggestion. Which is why this has gained a lot of attention lately. It's been around for almost 2 years, I think. But it's mainly, mostly in the last 6 to 9 months, it's really picked up big. The idea is, yeah, we do this in a way that is non-consensus breaking. This means, at the end of the day, someone still needs to actually post a transaction. And the way they've gone about to do this is that they have introduced what's called user operations. That is a pseudo-transaction object. You basically make a transaction into a little EVM Solidity data structure. And then you post these to something called a special network, where there are entities called bundlers, which will look at these user operations, much like miners will look at transactions and pick them up. The bundlers will look at user operations, pick them up, put them together, and make a few real transactions out of multiple user operations. And in order for these user operations to actually do something sensible, the bundlers will post these transactions targeting an entry point contract. This is a single smart contract which has the overarching logic for handling these user operations. And basically, much like generalized accounts, this is a 2-step process. You have the first step where you do verification/authentication. So the user operation is sent to a special function in the entry point contract, which returns all the user contract account. And then that's function, which again will say yes or no. The limitations again apply, very much like in the generalized account case. These verification and authentication functions can't change state, they can only read certain kinds of states associated with the account, these things. If the authentication passes, then there's the user operations pass to the execution logic. Again, this is implemented in the contract account, where you can specify which kinds of user operations you're supporting. The format there is completely open, so you can basically come up with your own encoding of your user operations. I don't expect many users to do this. There will be developers, of course, and there will be samples around this. There will be different flavors of user operations, and I would guess a couple of different ends of one context. And also, they introduced another actor here. They have something which is called a paymaster. Given the GitHub logic of lately, it should be called a paymay, but I don't know. That's what you guys mean. And they can assist with paying. So you have your user operation, you send 1 bit of code, 1 bit of code data to the verification, 1 bit to the execution logic, and there's the 3rd bit which will send to your paymaster, and the paymaster can handle either ERC-4337 tokens or actual tokens that pay for a contract size. So pay for the user operation size. And yeah, I already mentioned that the bundlers will treat the user operations basically more or less like that in that. Pros for this, no changes. There is no central actor. This is just a move. You don't know how to handle those. It covers most of the use cases for counterpart. It's very flexible. Since it's no consensus change needed, you just basically just deploy a new entry point contract, and that functionality is good. Once this has picked up interest, of course, it will be a big thing to change the entry point contracts. So, they have eventually you might be back to the same sort of progress there, but for the time being, it's flexible. You can deal with it. Some drawbacks, there's a bit of gas overhead, you have slightly increased possibility to do network service attacks. And you can only do one of these user operations at a time. There's no way to really sequence them in the first suggestion, at least. And it's good. That's in the second version for now. But there are instead multiple operations, so if one set of them together, you can only put one. Finally, to conclude, small comparison of generalized ones with these new suggestions. I have to admit that the ERC-4337 wins on flexibility. They can do all of these things, especially the things that generalized can't do with multi-operations. We can only run one transaction at a time. I've been thinking about extending that, of course. It seems fairly straightforward to extend the meta transaction to have a list of transactions, but maybe we should go there. I don't think we need it. Also, there is no way to pay with tokens in generalized math. I don't think there is in the ERC-4337, to be fair, either, because you still have to make an allowance, and how do you pay for making the allowance? I don't see anyone solving that. On the other hand, generalized account waits on simplicity for developers. Because we're writing actual transactions, there is no need to implement an execution mode. You're just signing plain number transactions, and everything there is already done by the node developer. Which is nice. That is one fewer place where you can use. That's about what I know about the counter-fraction, but I'm happy to try to answer questions if there are any. Thank you. Glad that's clear. Who's next?
Thank you. The next speaker will be Rando. We'll talk about what was called utility projects, smart projects earlier. See you? I can see it.